What if your dreams weren't just these fleeting, foggy memories you wake up with? What if they were movies? Movies you could actually watch over and over again. It sounds like something straight out of a sci-fi blockbuster. But today, we're diving into the incredible new science that's making it real. We're talking about decoding dreams.
I mean, really think about that for a second. What if those totally bizarre, sometimes wonderful, sometimes terrifying stories that play out in your head every single night weren't just gone when you wake up? What if you could record them, replay them, maybe even share them?
So here's how we're going to break this all down. First, we'll look at how science is starting to peek into our secret inner worlds by literally cracking the language of the brain. Then I'm going to walk you through how you'd actually record a dream step by step. After that, we'll zoom out and look at the bigger picture, the coming age of brain-computer interfaces. And finally, we're going to tackle the biggest question of all. In a world like this, is your mind still truly private?
Okay, so first things first. If you want to turn a dream into a video, you have to understand the language it's written in, right? And that means we have to crack the brain's own internal programming, what scientists call the neural code.
And this is where things get absolutely mind-blowing. This isn't science fiction anymore. Researchers have figured out a way to take the raw electrical activity from a person's brain while they're sleeping and reconstruct not just blurry images, but entire video stories from their dreams. We've gone way beyond just identifying objects. We're talking about rebuilding whole narratives. Yeah, I know what you're thinking. How on earth is that even possible? How do you take a bunch of electrical signals firing in someone's head and turn that into a movie? Well, the answer lies in this amazing field called neural decoding. Think of neural decoding like this. Every time you see, say, a cat, your brain produces a very specific pattern of electrical activity. It's like a unique neural fingerprint just for cat. What neural decoding does is build a kind of dictionary that matches all these different fingerprints to the things you're actually seeing. Once an AI learns that dictionary, it can do something amazing. It can work in reverse. It sees the cat fingerprint in your brain activity, and from that, it reconstructs the image of the cat you were seeing. Now, the main tool scientists are using to listen in on the brain is this big machine right here, the fMRI. It doesn't read your thoughts like a book, but it does something really clever. It tracks blood flow. See, the more active a certain part of your brain is, the more oxygen-rich blood it needs. So by watching where the blood is flowing, scientists can create a live, real-time map of your brain activity, whether you're wide awake or deep inside a dream. Okay, so we've got the language and we've got the tool to listen in. How do you actually put those two things together to record a dream? Well, it turns out to be this really fascinating three-step process. So here's the playbook. Step one is all about training the AI. A person lies at an fMRI machine and looks at thousands of different images. And all the while, the AI is learning to match specific brain patterns to each image. Step two, they do it for real. The person goes to sleep in the machine, and now the AI listens to their dreaming brain. It starts recognizing those same patterns it learned before, and from those patterns, it reconstructs the images from the dream. But here's the thing, dreams aren't just a slideshow, right? They're stories. And that brings us to the final brilliant step. They use a large language model, something like ChatGPT, to look at the whole sequence of decoded images and figure out the most logical story that connects them. It literally stitches those snapshots into a coherent video. So the big question, did it work? Incredibly. Yeah, it really did. When the researchers woke people up and asked them, hey, what were you just dreaming about? Their descriptions lined up very closely with the videos the AI had generated just from reading their brain activity. And we're not talking about vague similarities here. The alignment was stunningly precise. For instance, when one person said they dreamed of some cats, the AI, working only with brain data, decoded the category cat. Someone else described skiing with a snowboard, and the AI came up with skis. The system was clearly, undeniably picking up on the core ideas inside the dream. And crucially, this wasn't just some lucky guess. Statistically speaking, the odds of the AI's images matching the dream descriptions this well just by pure chance was less than 5%. Now, in science, that's the gold standard. That's the threshold you have to cross to say your result is significant, that it's real. This wasn't random noise. The system was genuinely reading the dream.
Now, as mind-bending as reading dreams is, it's actually just one piece of a much, much bigger puzzle. All this research fits into this rapidly exploding field called brain-computer interfaces, or BCIs, which are all about creating a direct link between our minds and machines.
So while that dream study used a big, non-invasive fMRI scanner, companies like Elon Musk's Neuralink are taking a way more direct approach. They're developing tiny implantable devices that create a high-speed link right into the brain itself. And believe me, the pace of this technology is just staggering. Just look at what happened in 2024 alone. The year kicked off with the very first human patient getting an implant and controlling a computer just by thinking. By the fall, an implant designed to restore vision got fast-tracked by the FDA. And then another study started to help people control robotic arms with their minds. This is not some slow-moving lab experiment anymore. This is a revolution that is happening right now.
And this technology really has this clear two-part mission. On one hand, you have this unbelievable therapeutic promise, helping people walk again, communicate, restoring autonomy to those who've lost it. But the second goal, that's way more ambitious. It's to unlock human potential by creating a brain interface for everybody. And that huge leap from therapy to enhancement is where we start running into some of the most profound questions of our time.
Because let's be real, when you create a direct link to the human brain, you're creating a link to our thoughts, our memories, our entire sense of self. And that brings us face to face with some of the most complex ethical challenges humanity has ever encountered. I mean, just think about it. Our neural data is the most private, most sensitive information that exists. How do we possibly protect it? If a device can read from the brain, could it also write to it, maybe influencing our decisions without us even knowing? And what happens to society when brain enhancement creates a brand new gap between the haves and the have-nots? These aren't just questions for a sci-fi novel anymore. They are urgent, real-world problems we need to start solving like yesterday. Now, the good news is this conversation is finally starting. Legal systems are racing to catch up, and it's leading to this whole new concept called neuro rights. You can think of these as basic human rights, but for your mind. The right to mental privacy, the right to your own free will. We're already seeing places like Chile and even US states like Colorado start to reclassify neural data, giving it the highest level of legal protection, just like our most sensitive medical records. So all of this amazing technology, from watching our own dreams to controlling computers with our minds, it all brings us down to one final, unavoidable question. When our innermost thoughts can be read, recorded, and decoded, who owns them? The answer we come up with for that question is going to define not just the future of technology, but the future of what it even means to be human.